Hello guys, my presentation is about wireless network security design and analysis using wireless intrusion detection system. First, network security is a constant battle between using and protection. Specifically in wireless networks, keeping a system accessible while blocking malicious actors is a major challenge. In this presentation, we are going to analyze the design of a wireless instruction detection systems, or WIDS, same. We will explore how open source tools, specifically Snort and Base and IP tables, can be integrated to create a robust defense mechanism. The focus here is not just on theory but on the practical application of these tools to detect and block real-time threats like denial of service attacks. To understand how we define a network, we first need to define what we are protecting. The effective security relies on five core pillars, often referred to as the CIA plus model. We have confidentiality and integrity. First, this ensures that data is accessible only to authorized users and remains unchanged during transmission. Then there is availability. This is crucial because if a network goes down, security becomes irrelevant. Finally, authentication and non-repudiation. These are verify the identity of the users and prove that transmission actually happens. However, attackers target these pillars using four specific categories of attack. First, interruption. Attacks that destroy hardware or cut the connection to stop service. Then we will have interception. This unauthorized access like wiretapping or package sniffing. Then modification, the tampering with data while it's traveling across the network. Then we will have fabrication. This is inserting fake data or malicious code into the system. Our primary focus is on preventing interruption and protecting availability. So how do we identify these threats in a live environment? We rely on two critical components, the detection engine and the analysis engine. For detection, we use Snort. Snort is an industry standard open source network instruction detection system. It operates in three modes: as a packet sniffer, a logger, or a full detection system. Essentially, it monitors network traffic in real life and compares it against a database of rules or signatures. If a package matches no threat, Snort triggers an alert, but rows logs are difficult to interpret efficiently. This is the where base comes. Base stands for Basis Analytic and Security Engine. Its functions are web-based graphical interfaces. It takes the complex data and generates it by Snort and visualize it, allowing administrators to stop attack patterns instantly rather than reading through thousands of lines of code. Now let's look at the specific threat model. The most common attack against the availability is denial of service, or DOS. In the standard DOS attack, a malicious actor floods a server with an overwhelming amount of traffic. The goal is to deplete system resource so that legitimate users cannot access the service. When this attack is launched from the multiple infected devices simulate with it often called zombies or the botnets. It becomes a disturbed denial of service, and DDoS, which is significantly harder to stop. For the purpose of analysis and testing, we use a simulation tool called Digital Blaster or DigiBlast. This tool generates continuous packet flows, allowing us to stress test the network. It helps determine if destination IP is vulnerable and our security measures can withstand high traffic conditions. Detection is only the first step to actually stop an attack. We need a defense mechanism in a Linux-based environment. The most effective tool for this, the IP tables. The IP tables acts as a firewall built directly into the Linux kernel. It controls the flow of the packet using the system of chains, especially input, output, and forward chains. The logic is straightforward. When a package enters the network, IP tables check it against a list of filters and dedicate its fate. It can accept the package and let it pass. It can log the activity for the future analysis, or it can drop and reject the package, efficiently blocking the intrusion. Once Snort detects a threat, IP table is the component that enforces. Let's examine the architecture of such a system. And the design follows the SPDLC for model, which stands for Security Policy Development Lifecycle. In this simulation designed using Cisco Packet Tracer, we can see a realistic network topology. Here we have wireless router API connecting various client, central server, and external intruder machines simulation the attackers. The critical design choice here is the placement of the NIDC. It's positions to monitor the entire network segments. This ensures that it has visibility over all traffic flows, not just the traffic going to a single computer. This is what differentiates of network IDS from the host IDS. When the system is put on the test under the simulated attack, the results demonstrate the interaction between detection and defense. During the attack phase, where ping flows and digital blaster attack the irritated, the network immediately experiences abnormal traffic spikes. The first is detection. The detection snort is successfully identify the packet by matching them with the pre-configured signature rules. Alerts appears instantly on the base interface, providing detailed information about the source of the attack. The second is the response. The system does not just log the event, it reacts. IP tables dynamically block the attacker's IP address. Additionally, MAC filtering is applied. This is a crucial step because it's the blocks the specific hardware address of the attacking device, preventing them from simply changing their IP to bypass the firewall. The result is the attack is neutralized and the servers remain operational for the legitimate users. To conclude this analysis, the integration of snort-based and IP tables provides a highly efficient open-source security solution for the wireless networks. We have demonstrated that real-time detection is achievable with minimal latency. Visualizing tools like BASE are essential for quick analysis. IP tables offers a robust kernel-level defense against the intrusion attempts. For this implementing similar system, here are key recommendations. Layered security. A double IDS should complement existing security measures, not replace them. Early detection. The proactive monitoring is always more efficient than the reactive damage control. Updates and training. Security is dynamic, keeping signature database current and ensuring the teams are trained to interpret alerts just as important as the software itself. Thank you for watching.